Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will continue with the extreme heat protective clothing. Now, here in this module we will start with the innovations and future trends for the extreme heat protective clothing. So, let us see what are the innovations and future trends. So, first is the smart textiles. So, we should embed different types of sensor for real time heat and physiological monitoring. Automatically the clothing will get adapted and react accordingly. So, adaptive materials we can also use within the structure like shape memory polymer or phase change material, okay. And sustainable fire retardant materials are now in the future trend, and it is bio based aramid are have been developed, and green coatings with more than 60% renewable contents. So, we should go for the sustainable materials and also the nanotechnology. It is nowadays widely used in the nano coating or aerogel formation for lightweight material and improved thermal resistance. So, these are the trends. Let us discuss these issues in detail. So, if we integrate the say temperature sensor that detects the change in temperature both in environment and the human body within plus minus 0.5 degree Celsius accuracy. So, that is very important to sense the temperature change, and real time monitoring is there. So, wireless data transfer, very quick transfer of data, and real time in some control room that can be controlled. So, what is the situation of the firefighter or the worker working in extreme heat condition, and cell powered option is there for energy harvesting up to 20 to 50 micro ohm per square centimeter that can be generated, and adaptive response. So, triggered cooling or heating when temperature exceeds. So, this can be used for extreme cold and extreme heat condition. So, when the temperature exceeds by 30-35 degree Celsius, and that in that case the trigger can be it will be cooling may be triggered. So, that will help in getting the body maintaining the body heat. And next is the shape memory polymer. So, with the change in temperature both in extreme cold and extreme heat condition, that the polymer will get shape will get changed. So, suppose a clothing in normal temperature there is no air gap, but if the temperature increases and we need air gap to be there created inside the fabric, in that case if we use the shape memory polymer. So, with the change in the temperature that will shape will change and the air entrapment will increase and give the necessary insulation, and when the in normal temperature it again come back to its original shape. So, activation temperature typically 40 to 80 degree Celsius, turnable for protective textiles, okay. And this can be tuned for the protective textiles. Shape recovery ratio, it gets recovered more than 95%. Response time is within 10 to 30 seconds. It is actually the it gets shape gets changed, and durability maintain functionality. Basically it is more than, it has been observed more than 200 thermomechanical cycle, it maintains its performance. Then sustainable material development, bio-based aramids have been developed, and green coatings. So, like you can see the bio-based that Rilson P811 blends. So, that is actually bio-based aramid up to 70% renewable content. LOI is more than 28, and green phosphorus coating. So, that is actually that can be used for FR class D1 to D2 as per ISO 15025. Lignin based FR finish can be used, and nanosilica and alginate hybrids, that can be used as a coating material, improve thermal stability. And like types of extreme heat or firefighter clothing, let us see what are the different types of firefighting clothing. There are mainly two types of firefighting clothing. One is proximity firefighting clothing, where the firefighter has to go close to the fire situation, extreme heat, and in those cases the main requirement is to reflect the heat. So, reflective aluminized coating is there, and which is actually used for the proximity sense firefighter. Another is a structural firefighter, where the person has to enter inside the fire and remains protected. So, that where we fire retardant fibers are being used and high insulation is required. So, structural firefighter clothing. So, this is the structural firefighter clothing, where firefighter has to enter inside the fire situation. So, this there is a coat, it is a coat, it consists of the outer shell, moisture barrier layer and thermal liner. So, this in the coat, if he should use this material with the 3-layer structure and reflective strip. So, this is the reflective strip which will give the high visibility and will detect the presence of the firefighter inside the fire. So, that one can easily detect the presence, and pockets are created for carrying the essential materials along with them during the operation. So, in the coat there must be some pockets present, and closure, heavy duty zippers are there, or the velcro or snap closure, and those zippers, velcro and snap closures are it should be fire retardant, this should made of the fire retardant material, and there must be reinforcement at different portions of the coat, where heavy stress is generated, like the elbow, shoulder. So, extra durability is required, so that it remains intact, structure remains intact. This is the coat's construction, and next is the hood. So, hood is for protecting the head, where basically it shields vulnerable areas like neck, face, ear from burn, and that is that in and extreme heat exposure. And it should be flame resistant. The material is designed to resist ignition, reduce risk of burn hoods, and it should be comfortable. This wood material, in addition in the here the fire retardant helmet. So, they should wear the hoods, and during the fire situation this the extreme heat is generated, and at the same time moisture vapor is generated. So, there should be it should be comfortable, okay, in high stress situation, and it should be safety related issues are enhance the overall protection when used in conjunction with other firefighting equipment like such as helmet, turnout coat. So, that the different gadgets are there. So, and then comes the trouser. Trousers construction is almost similar to the coat. It consists of outer shell, moisture barrier layer, and thermal liner. So, that this functions of each layer we have already discussed. The reflective strips, high visibility strip is again there for the trouser. For the same reason, pockets are incorporated for carrying essential, and reinforced knee and calf, where the frequent bending and stress applications are there, we need the reinforcement, like in knee area frequent bending will be there. So, that to prevent the trouser from damage. So, we need a reinforcement. So, articulated knees are designs, okay, designed for better mobility, comfort, and allowing firefighter to move freely. So, this type of materials are being used. Next is boots. Boots are basically it consists of again three basic components: outer shell, which is fire protective shell lining, and sole. Sole to actually prevent any slippage and protect from any other hot or any mechanical damage. Heat and flame protection, the sealed feet and lower leg from the extreme heat, durability built to withstand rough condition, abrasion, etc., and puncture resistant, that its steel or composite shanks protect from sharp objects. So, this sole this should be made of composite, hard composite or steel, so that it protect the from the any sharp object to penetrate, and traction slip resistant sole. So, this slip resistant sole is very much important to keep the stability, provide stability on slippery and uneven surface. So, the in case of firefighter, the basic condition is that you will see that water will be splashed, and there will be slippery, and the surfaces will be definitely not very smooth or maybe uneven surface. So, in those cases to prevent slippery, special anti-slip soles are provided. So, gloves are again it is having 3 layers: outer shell, thermal liner, and moisture barrier, and it should be cut and puncture resistance, because the firefighter works at a higher very high temperature, and he has to grip many such material like objects like glass, debris, okay, different. So, it should be protected from all these objects. It should be chemical resistant. So, because it harmful chemical should not be come in contact with the hand. So, and it should grip the material, and now if you see the layers, outer layer, middle layer and inner layer, and face fabric is there. This is the face fabric which is in contact with the human body. The outer layer, it is basically thermal protective reflective layer. So, thermal protective layer is basically for structural firefighter, and reflective layer is basically for the fire. This is for other type of material where we can use the aluminized coating, and it is called shell fabric. It resists ignition. Okay, outer layer it should resist the ignition and protect from radiant heat and flame. So, that is why if in case of structural firefighter clothing, this should be compact in structure. So, that radiant heat should not come, and flame also should not penetrate inside. It should be stopped at this point. Okay. Abrasion and cut tear resistant. So, it should have higher tear resistance or because the outer shell fabric, outer layer comes under different types of mechanical actions, and resistance to chemical. So, in case of any chemical spill or chemical drop comes, it should be resistant. So, that the looking at all this, we should select the structure of the fabric and what type of fibers we have to use, and resistant from thermal shrinkage. So, we should use the fiber in such a fashion, so the extreme heat condition, the thermal shrinkage should not be there, or if at all it is there, it is a very low level, less than 5%, that we have already discussed. So, materials used for outer layer fabric. So, aramid fibers and its blends, that is very commonly used for the outer layer fiber, PBI fibers and its blends. PBO fibers is also used in the outer layer, and coated material. So, we sometimes use coated material for different types of coating, like water proof coating, or maybe different types of graphene coating, or different types of anti-fire, actually fire resistant clothing coating we use. Now, materials used in the outer layer. So, meta-aramid, para-aramid. So, blends of meta and para-aramids we use for the outer layer, like for PBI fiber, PBI with blends of meta-aramid, that we use at different 50-50 blend and 75-25 meta-aramid PBI blends are very commonly used. And PBO fibers normally not used in 100%. So, with a meta-aramid we use 50-50, 75-25, and with a para-aramid also we use PBO. So, different types of blends are being used as a outer layer, and coated material you can see aluminized coating, coated meta-aramid fiber. So, and glass fiber coating, and glass fiber also we use in the outer layer, and in the middle layer, which is moisture barrier layer, that is moisture vapor from the human body will can easily pass through this layer. Now, try to see, this is the middle layer. So, here the outer layer is actually protecting us from the direct flame, radiant heat, and all this. So, middle layer main function is the to create the moisture barrier. So, it should be resistant to heat and flame. So, that is important, it should not get melt easily, it provides breathability to the structure. So, the moisture vapor should transmit through this middle layer easily, but at the same time it should prevent the water to penetrate, water or any chemical to penetrate through this layer, and it should provide the comfort characteristics. Due to the breathability, it will provide the comfort characteristics, and it is resistant to UV degradation. So, that is true for the outer layer also, and it should allow the physiological heat transmission. So, in case of fire condition, it will prevent the heat from outside to inside, but in case of not when the person is not active in front of fire. So, at that time the middle layer should allow the heat to get transmitted to the environment, so that it keeps him comfortable. So, materials are basically aramid fibers and its blends are used, or sometimes regenerated cellulose fibers are used in case of middle layer, and all it is coated with say different types of coating to keep the pore size inside in this layer, which allows the moisture vapor to pass through. Now, we can see the aramid fibers and its blends are used in the middle layer, like meta-aramid, para-aramid, and meta and para-aramid combinations that we have already discussed for the outer layer. In the middle layer, similar blends are being used. Now, coated material, you can see that the material, like typically it is a non-woven fabric, okay, and here in this non-woven or maybe woven fabric we can also use, and here its coating is done. Coating is done. This is the coating, and the coating's function, coating may be with the PVC coating, polyvinyl chloride, polyurethane coating also used, and polyether sulfone. So, that PES, this type of coatings are generally used, which are heat protected, it does not melt easily, and also it creates the pores, and which allows the moisture vapor to pass through this pores during the activity. So, that to keep the person comfortable. And regenerated cellulose, that is viscose fiber with flame resistant or retardant coating materials are used in the middle layer. And inner layer, which is called thermal liner or thermal barrier, and the main function is to provide the insulation. So, this is inner layer, this is resistant to external heat flow through the clothing. So, that is important, it should not allow the external heat from outside to penetrate, and it is a heat blocker, okay. High breaking strength to the structure, otherwise the structure disintegration may take place, and it should be stable, thermally stable, and provides resistance to mechanical hazard and chemical hazard. So, in provide comfort characteristics, resist thermal shrinkage and UV degradation. So, this should not be shrinkable. So, we should use the such material which will be in which the shrinkage characteristics is low, shrinkage value will be low. Now, try to see the what are the different materials being used. So, aramid fibers and its blend same as the other two layers. Now, here main function is to have the high insulation. So, aerogel may be incorporated, aerogel aramid fiber based composite is used. So, in suppose this is aramid fiber and aerogel is incorporated within the structure. So, structural integrity is there and aerogel is being highly insulating, it will increase the insulation characteristics. FR cotton and its blends, we can use the fire retardant cotton fiber and their blend. So, aramid fiber same aramid fibers can be used, meta aramid, para aramid and their blends we can use here, and aerogel aramid fiber based composite. So, that is very nice material here. So, where thermal insulation is increased with a greatest extent. So, aerogel is one of the best thermal insulator available. The main problem of aerogel is that it is a brittle. So, we can now research are going on to create the aerogel flexible. Okay. It provides excellent protection against the extreme heat condition, and aerogel it is a very low density. So, the weight of the fabric is reduced to a great extent. Despite high insulation properties, aerogel is very light, contributes overall comfort. So, we can create lightweight thermal protective clothing, and porosity if you see it is highly porous structure, and as it is highly porous. So, it can trap the steel air which enhance the thermal resistance. You can see here the inner layer, what are the different materials we can use, as we have FR cotton and its blend as we have mentioned. So, self extinguishing FR cotton. So, a cotton fabric is treated with the FR fire retardant treatment, and due to its natural fiber and its breathability is high, make it comfortable and prolonged wear. Okay. So, it is comfort by nature, cotton is comfortable. So, it will make the fabric total clothing comfortable. Now, multidirectional thermal protective tester that we have already discussed in previous section. So, here this is the motor which can move this sensor here, and to adjust the distance between the fabric and the sensor, and heat and humidity can be measured here. Quartz heater is there for, this is a quartz heater, it is for the radiant heat source and also the burners for flame, and in this instrument it can rotate, this total platform can rotate at different angles. So, here what we are trying to discuss here, the specifications of these components, and also one small research study I would like to show you. So, how the direction of heat source changes the thermal protective performance. So, multi-directional TPP tester that we have already discussed. Now, I am not going to discuss show it once again. So, here radiative and flame will be there as a source, and you can see here. Now, these are the different heat sources. So, radiant heat source is here with a 9 quartz bulb as per the standard is provided. So, it can give generate up to maximum up to 45 kilowatt per square meter heat flux. Intensity can be controlled by rheostat to control this heat flux, and convective heat source, here heat flux can be as high as 100 kilowatt per square meter. So, 2 Maker burners are used, and here we can use methane or propane gas as per the standard. So, radiant heat, as we have discussed, intensity can be controlled by rheostat. Convective heat we have discussed. Now, other important features are that PLC based data logging here. So, this is the we can get the data from the source. So, it is a PLC based. So, we can provide the change the air gap as we have discussed by moving the position of the sensor with respect to fabric specimen, and rotational mechanisms are created to provide at different angle. We can test auto cut ignition. So, we can cut the same this fire depending on our requirement. We can cut the ignition or auto ignition, we can start the ignition. So, that we can do automatically through computer, and second degree burn time is measured to measure the thermal protective performance characteristics. Now, the software interface to start, control, run, stop and analysis the data. So, through everything is done through software. We can start the instrument, we can control the position of the inclination, we can run, we can stop the machine, and after that through software we can analyze the data. Now, this is the schematic representation. So, here we can see the heat source is from the top. This is the heat source, and fabric is placed horizontally at the below the heat source, and here the sensor is at the bottom. This condition we call it as 0 degree condition. So, at 0 degree condition, so when the heat source is coming from the top, so that is 0 degree, and 180 degree when it rotates at a different angle and rotates total 180 degree angle, where heat source is at the bottom and fabric is at up above that, and then sensor is there above the fabric. So, this is the situation where we call it as 180 degree situation. So, at different situation we can have the this type of curve. Now, here we can see this is the situation here, like in A the sensor is here and heat source. So, vertically this is the condition and heat source is at a horizontal condition. B you can see at certain angle. So, it is angle with the horizontal plane. So, this is the angle. Now, it is C where you can see the C heat source is at from the top, it is a 0 degree condition, you can see it is a 0 degree condition, and D the heat source is from the bottom. So, it is a 180 degree condition. So, that means when the heat fire is at the top, okay. So, from there the whatever heat is coming inside on the clothing, that will be considered as 0 degree exactly. If suppose fabric is there horizontal condition, heat is from the top, and opposite is that when heat is exactly in the vertical direction, it is called 180 degree orientation. Now, let us try to see the now this is the condition, here our skin is there, heat is coming from the top, it is a 0 degree condition. Okay. At certain theta degree, say theta say maybe 45 degree. So, this is the, and here it is a 180 degree where heat is from the bottom. Okay. So, this is 180 degree condition. So, with this condition we have actually we have studied a particular fabric, different types of combinations with different angles. So, and we have measured the TPP rating at different angle. Now, let us see the result. So, current bench scale test method, these methods are limited to fixed orientation. So, bench level test methods where we can either orient in the horizontal mode fabric or maybe fabric in the vertical mode. So, but which is which limits the real world scenario. So, in real world scenario the fire can happen from any orientation. So, we must know the thermal protective performance of fabric at different orientations. As the orientation changes, the heat transfer through the fabric clothing ensemble it changes. When there is a significant temperature difference across the air gap, density varies cause the buoyancy and force that driven convective motion. So, that means where the fire is at the from the bottom. So, due to buoyancy the heat will actually through convection, natural convection heat will flow. So, here heat actually through convection heat will flow more. So, in this 180 degree condition the heat flow condition is supposed to be highest, and in 0 degree condition because it is heat is from the top. So, buoyancy, due to buoyancy the hot air will move up. So, that in that case the extent of heat, intensity of heat should be lower. So, that was our assumption. So, we have proved with the experiments, and in at different angle this will be intermediate situation. The protective performance at different orientations may bring new opportunities to redesign thermal protective clothing. So, that is very important. So, we must know the at different angle what would be the thermal protective performance. So, that is very important. Now, let us see with this experimental result what we have done. We have tested with the two different types of intensities. Okay. So, test result you can see here. So, figure 1 we have to at certain intensity, but two different types of air gap. So, in this is the figure 1 where the this is the fabric specimen and here we have the sensor. So, this one is the sensor, okay, and fire is coming. So, in this case the distance between the air gap distance which is 12.5 millimeter, okay, and in other case in figure 2 it is a 6.4. So, another figure, another case where this is figure 1 and figure 2, this is figure 2, figure 1, figure 2 the distance is reduced, it is reduced to 6.4 millimeter. This is distance is 6.4 millimeter, and let us try to see what is this. So, this at 0 degree position, 0 degree position, what is 0 degree position? When the fire is from the bottom, this is the 0 degree position. At 0 degree position, you can see the second degree burn time is 0 degree orientation is from the top, and 180 degree is from, this is 180 degree and this is 0 degree. So, 0 degree orientation when fire is from the above the fabric, that means due to natural buoyancy the convective heat will move upward. So, that will that means effect on the fabric will be reduced, the thermal effect will be reduced. So, in that case maximum thermal protection time is there. So, protection time is 101 second at 0 degree, and if we change when as we go on changing the orientation, that protection time is reduced gradually, and finally at 180 degree orientation when the heat is from the from below the fabric, okay, in that case the protection time is least here at 72 second, and when we change the or when we reduce the gap from 12.5 to 6.4 millimeter, in that case we can see the protection time is reduced consistently. So, here at 6.4 millimeter gap, it is at 0 degree orientation it was 74.6 second, and at 180 degree orientation this is the protection time has reduced to 49.4 second. So, that is how we this is very clear that with the orientation the protection time consistently changes. Let us see once again. This is the experiment was done. Here the angle is 90 degree because it is a vertically oriented fabric. So, you can see this is the 90 degree orientation. Now, here this is tested. I will go now we are placing the fabric once again, and now the experiment is at 90 degree orientation. Here it is tested. So, and then we can analyze the data. Now, to try to see the ergonomics, what are the different types of physical load and energy demand in case of the firefighter suit. So, firefighter the task combined with personal protection clothing used to lead high physical load and significant energy expenditure. So, they need to have very heavy load during the extreme condition. Activities such as fire suppression is the main activity, then they have to search the location and rescue, which amplifies the physical stress. So, they have to move very fast with the heavy load with them, and here improperly designed the cloth, ergonomically designed cloth will actually increase the metabolic burn and also restrict the body movement and reduce the comfort. So, comfort focused design is essential, very much essential to maintain the performance and fatigue resistance. So, the person should be comfortable during his performance. Now, clothing system mobility. So, it should be the person should move freely, and that this we have already discussed, we have shown, but let us see once again. Now, see this here, this type of mobility should be there, ergonomically they should feel comfortable, because they are carrying, they are supposed to carry the heavy load, and the clothing should be lighter enough, and the body movement, it should not restrict the body movement. At the same time the protection level should be very high. So, this we can see the different types of activities they used to do. So, this is the where trial technique is going on. They should be able to run smoothly. Basic thing is that the mainly moisture vapor transmission, ergonomic design, body, it should not restrict the body movement in all these conditions. The number and thickness of layers directly affect the mobility and thermal comfort. So, the number and thickness of layers directly affect the mobility, okay, and thermal comfort. Increased weight. So, the thickness should not be very high. So, it will restrict the mobility, and the garment weight should be low, and it should be reduced so that easily body movement, one person can make the movement easily with the load. He has to carry different types of loads, and the PPE, firefighter PPE typically shows density of 74 to 597 kg per square meter cube. So, that it is within that range, density should be, the total weight often exceeds 3 kg, but the firefighter clothing, the structural firefighter clothing with the total weight less than 2 kg was developed. Proper sizing and garment body proportion help minimizing the movement restriction. So, we should be very careful in so that the body movement restrictions are not there. So, in addition to the clothing, there are some additional gears required. So, we must know what are the this additional gear which protects the human during the firefighting conditions. So, modern tools like night vision, alarm, detectors, communication device. So, these are the part of the firefighters, those who were carrying, and but this in turn increase the overall load. Helmet and self-contained breathable apparatus, okay, that some mask, they special mask they should use to protect them from the hazardous gas. So, used may limit head and arm mobility, okay, reduce access to the pocket and tools. Reported concern including back pain, soreness and restrict motion is there. If we add all this gear, but this gears, additional gears are very important. Ergonomically optimized PPE, so that if we can optimize the PPE which balance the protection with the comfort. So, that is important and which will enhance the operational performance. So, standard ergonomic design. So, there are different types of standards. EN 340 being replaced by ISO 13688 outlines the general requirements for ergonomics, okay, sizing, aging. So, different types of standards which will specify the requirements. The standard specifies the manufacturer provided information essential for safe and correct garment use. So, there are different types of standards one must follow. So, the protective clothing must be designed to be as lightweight as possible without compromising the protection. So, if we can design lightweight, so it will enhance the performance, but at the same time protection should not be compromised. So, key design factors include comfort, water vapor resistance and ergonomic construction. So, we have covered the fire protection or extreme heat protection aspect. Next session we will start with another protective clothing, and we will discuss the extreme cold protective clothing. Thank you.